In this video, we're going to review some things and then kind of close up Chapter 5 on probability. So, first of all, sketch the Venn diagram and then answer the following questions. Okay, I'm going to sketch it kind of off to the side here. So we've got A, and we've got B, like that. The probability of A and B is 0.08, so that goes in the middle, which means the probability of A alone is 0.16, and the probability of B alone is 0.37, because, of course, they have to add up to be 0.24 and 0.45, respectively. So what's left over when we add those things up is 0.39. So I always like to write down what's left outside. All right, so what's the probability of A complement? Well, it's the probability of not A, so 1 minus the probability of A. It is 0.76. The probability of A or B, so we simply add up these three pieces, or you could add these two up and subtract off the intersection with that new addition rule, right? 0.24 plus 0.45 minus 0.08 is 0.61. The probability of A but not B, we can use the Venn diagram to see that's 0.16. Probability of B but not A, use the Venn diagram again, 0.37. The probability of A or neither A nor B, so that's that 0.39 that was left over. And the probability of A or B but not both, well, now we just want to add up the two sides of the circle, 0.16 and 0.37. We get 0.53. Using the table to the right, find the totals for the boxes. All right, well, let's put those totals in. So 15 plus 23 is 38. And then we've got 12 plus 23 plus 28 for a total of 63. Either way, this is 125. So the probability of A, well, there are 27 people in A out of 125. Probability of C, there are 60 out of 125. The probability of A or E, so now we look, you've got A here, you've got E here, so 27 and 63. 27 people on A, 63 people on E, but we have to subtract off the 12 people that have been counted twice, right? These 12 people were counted in both. So 63 and 27 minus 12 is 78 out of 125. Probability of A and D. So now we just go to this right here. It's this group. So 15 out of 125. And finally, I always go to the formula here. The probability of B given D is the probability of B and D over the probability of D. So the probability of B and D is 15 out of 125. And the probability of D by itself is 62 out of 125. You could reduce that to be 15 out of 62. So closing up our discussion here of Chapter 5 with some definitions. What does it mean if two events are disjoint? It means that two events cannot occur at the same time. Okay, to think about it with a Venn diagram, those two events are like this. Here's A, here's B, they have no overlap. What does it mean if two events are mutually exclusive? It means the same exact thing as if they're disjoint. Those are the same terminology. What does it mean if two events are complements? Well, really, the key here is that it's the probability of an event and then the probability of that event not happening. So there are some things here you could talk about, like they constitute an entire sample space. They add to 1, therefore. Okay? All right. What does it mean if two events are independent? It means that if one event occurring does not affect the probability of the other. Best example, easiest example, of course, is flipping coins. Each flip is independent of the flip before it. The probability is still 0.5. All right, looking at some notational things I just wanted to highlight here. This right here means or. But remember, it also implies both. So if it's A or B, that represents adding up not only this circle and this part, but also the middle. It's all of this inside. The little c means not, okay, not A. Okay, so the bottom part, probability of A and not B. Okay, so A and not B. So the upside down means and, the upside down U. All right, we've learned some formulas here. What's the probability of A or B if A and B are disjoint? Well, let me go back to my picture. Disjoint means they're like this. So if this is A and this is B, it's simply the probability of A plus the probability of B. Now, here I wrote, I kind of left some space. So A or B, there's kind of a, let me start by just saying if we don't know if they're disjoint. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay, and this, of course, is this Venn diagram like this, where you have to add up A and B, but then you have to subtract off the fact that you've counted the intersection twice. Now, if they're independent, okay, independence, remember, gives us the ability to find the probability of A and B through multiplying. We can do probability of A and B. So we could do probability of A plus probability of B minus the probability of A times the probability of B. Like that. Okay? So again, I just want to highlight that independence gives us the ability to say these things are equivalent. That the probability of A times the probability of B is equal to the probability of A and B. And finally, the probability of A given B, remember this formula, A and B divided by the probability of B. Closing up this chapter on Venn diagrams, let me begin by I always like to figure out what the leftover portion is. So A by itself, B by itself, A and B. These add up to be 0.87. So there's 0.13 left outside. All right? So the probability on the first one of A or B, well, that is that 0.87. Next, we've got the probability of A and not B. So that, of course, is this portion right here, A but not B. That is just 0.34. The next is what's the probability it's not A and it's not B. So this is the leftover because it's not been included in either part. And then we've got the probability of not A. So what I would maybe think of real quick is the probability of A by itself is 0.46. So the probability of not A is 1 minus 0.46. It is 0.54. Okay? And the probability of B by itself is 0.53. So the probability of not B is going to be 0.47. And the probability of A, of course, is 0.46. Now, a couple of things I just wanted to highlight here. If you were asked for the probability of A given B, remember that's the probability of A and B over the probability of B. So this is an often mistaken formula because people will say, well, I know the intersection is 0.12, and they'll accidentally put the bottom as 0.41. But remember, the probability of B is the total circle, so it's 0.53. Okay, so remember to be careful with what the probability is really inside the whole circle. The other thing I wanted to visit about was independence. Remember, if things are independent, let me make a little note up here, then the probability of A multiplied by the probability of B is equal to the probability of A and B. So that we could check that here. We could say, well, is 0.46, the probability of A, multiplied by 0.53, is that equal to 0.12, the probability, according to the Venn diagram, of A and B? And if you multiply 0.46 times 0.53, you get 0.24. So the answer, of course, we've got to make this a not equal right here. The answer is no. They are not independent. They are dependent. And finally, closing this video about independence with things we've already talked about. Okay, so I may just visit here. What does independence mean? It means the probability, or the fact that one thing occurs does not affect the probability of the other. What does independence allow us to do? It allows us to multiply independent probabilities together. Okay, it allows us to say that the probability of A times the probability of B is how we could find the probability of A and B. And the last question, how do we prove independence? By verifying that that formula works, just like we did with the Venn diagram on the previous part of this video. Okay, so that closes up Chapter 5.